we have already studied about the circulation of ocean currents in the Pacific Ocean and Atlantic Ocean. Today, we will study about the circulation of ocean currents or gyre in the Indian Ocean. Firstly, we will study about the northern half and then we will study about the southern half of the Indian Ocean. This is a scenario in the summer season. During summer, the land gets heated up. Therefore, the air above the land being hotter and lighter rises up, creating a low pressure area over the land. Whereas the water bodies are comparatively cooler. Therefore, the air above the sea being cooler and heavier sinks down, creating a high pressure area. Now we know that winds always travel from high pressure to low pressure area. Therefore, during summer, the winds travel from sea to land or from high pressure area to low pressure area. Now, since these winds originate from the sea, they pick up moisture and cause rainfall over the land masses. So, during summer, we experience rainfall. Now, let us understand the situation in context of India. See, this is a map of India and we can see a low pressure region over the Indian subcontinent. Why so? Because during summer, due to high temperature, the land gets heated up and therefore the air above the land is hotter and lighter, therefore rise up, creating a low pressure area over the landmass. Whereas the adjoining water bodies, that is Arabian Sea, Indian Ocean and Bay of Bengal, are relatively cooler. Therefore, the air above these water bodies is also cooler and heavier. Therefore, they descend down, creating a high pressure area over the water bodies. Now, we know that the winds always travel from high pressure area to low pressure area. Therefore, we can see this kind of movement during summer, that is, the monsoon winds travel from adjoining water bodies to the Indian subcontinent during summer, or the winds travel from sea to land during summer. And since these winds originate from the water bodies, they pick up moisture and cause rainfall in India. And therefore, during summer, we find that hot, humid winds carrying moisture travel from sea to land and cause rainfall over the land masses. Now, let's see what happens during winter. Now, this is a scene during winter season. During winter season, the land is relatively cooler. Therefore, the air above the land is also cooler and heavier, so they sink down, creating a high pressure area over the land. Whereas, the water bodies are relatively warmer. Therefore, the air above the water bodies being warmer and lighter rise up, creating a low pressure area. Now we know the winds travel from high pressure area to low pressure area. Therefore, during winter, the winds travel from land to sea. Now, since these winds originate from land, they are dry and they have no moisture. Therefore, during winter, we do not experience any rainfall as the winds travel from land to sea. Now, let us understand the same situation in context of India. This is a map of India and now we are in winter season. During winter, we have high pressure area over the Indian subcontinent. Why so? Because during winter, the temperature of the land mass is comparatively cooler. Therefore, the air above the Indian subcontinent is also cooler and they are heavier. So, they sink down, creating a high pressure area. Now, look at the water bodies, that is the Arabian Sea, Indian Ocean and Bay of Bengal. these adjoining water bodies are relatively warmer compared to the land. So the air above these water bodies is also warmer and lighter, so they rise up, creating a low pressure area. Now we know that winds always travel from high pressure area to low pressure area. Therefore, during winter, we find that the monsoon winds blow away from the Indian subcontinent to the adjoining water bodies during winter. Now, these monsoon winds are dry. Why so? Because these monsoon winds originate from the landmass and therefore they pick up no moisture, and therefore we experience no rainfall during winter. Now we will see how the presence of these monsoon winds affect the circulation of ocean currents. This is a situation in the summer season. We have studied that during summer season, the winds or the monsoon winds blow from sea to land. So, the monsoon winds travel from southwest direction. See, they are moving from southwest. So, these monsoon winds also influence the ocean current to blow in that direction. That is, the ocean currents also blow from southwest direction. Now, you see that these ocean currents have two branches, the Arabian Sea branch and the Bay of Bengal branch. In both the branches, the ocean currents travel from southwest direction. See, in both cases, they are traveling from southwest direction. So, the ocean currents that are prevalent in the Indian Ocean during summer are called the southwest monsoon drift. So now let us understand the circulation of ocean currents during summer in the Indian Ocean. In the Indian Ocean, we see that the ocean current travel in southwest direction in the Arabian Sea and in the Bay of Bengal region. A gap is created over this region, and now the equatorial counter current, which travels across the equator, moves from west to east to fill this vacuum. Well, although it is the northern hemisphere of the Indian Ocean, here we do not see that the ocean currents follow clockwise pattern. Here the ocean currents do not follow any clockwise pattern. Why so? Because here in this region the ocean currents are influenced by the presence of monsoon winds. Because the monsoon winds travel from southwest direction, therefore the ocean currents influenced by them also travel from southwest direction during summer. Now we will see what happens during winter. We have learned that during winter, the dry monsoon winds blow from land to sea. Therefore, the monsoon winds actually travel from northeast direction. Now, the presence of these monsoon winds affect the movement of ocean currents. How? The ocean currents also travel in northeast direction. See? Again, we can find that the ocean currents in the northern part of the Indian Ocean have two branches, the Arabian Sea branch and the Bay of Bengal branch. The ocean currents originate from the equator and they move in this direction. Then they are deflected by the shape of the landmass and they are influenced by the monsoon winds. Since the monsoon winds blow from northeast direction, see in both cases, therefore the ocean currents also blow in northeast direction during winter. And therefore the ocean currents that are prevalent in the Indian Ocean during winter are called the northeast monsoon drift. We can again find the equatorial counter current. The equatorial counter current, which flows along the equator, moves from west to east. The equatorial counter current actually flows in this direction to fill the vacuum created by the northeast monsoon drift. In the northern half, the northeast monsoon drift blows away from the equator in this direction. So a vacuum is created along this region and equatorial countercurrent blows along this direction from west to east to fill this vacuum. Now, did you see the ocean currents are changing their direction in summer and winter? In summer, they are flowing from southwest direction, whereas during winter, they are flowing from northeast direction. So, this phenomena of change in the direction of ocean currents is called seasonal reversal of ocean currents. That is, due to change of seasons, the movement or the direction of ocean currents also changes, and therefore we do not see any clockwise movement of ocean currents in the northern half of the Indian Ocean. This is very unlikely because in the other oceans, in the northern half, we can find that the ocean currents move in clockwise direction due to Coriolis effect caused by Earth's rotation. But here we do not find any such movement. Why so? Because of the presence of monsoon winds. The monsoon winds are very dominant over the northern half of the Indian Ocean, and therefore we do not find any clockwise movement. The ocean currents are actually very much influenced by the monsoon winds, and they follow the direction of monsoon winds. Now we will see what happens in the southern part of the Indian Ocean. Before we proceed with our lesson further, can you help me to answer this question? In which direction does the monsoon drift flow during winter? Does it flow in northeast direction, southwest direction, southeast direction, or northwest direction? Well, we have just studied that since the monsoon winds blow from land to sea, that is, they travel from northeast direction during winter, the ocean currents or the monsoon drift also travel in northeast direction. Therefore, the correct answer is northeast. And so, these monsoon winds that travel in the winter season are called the northeast monsoon drift. Now, we will understand the circulation of ocean currents in the southern half of the Indian Ocean. In the southern half, the gyre or the circulation starts with the south equatorial current. As you can see that the south equatorial current is a warm current as it is marked by red, so it is a warm current. Now, why south equatorial current is a warm current? South equatorial current is a warm current because it originates in region of high temperature, that is torrid zone. Now, the south equatorial current travels from east to west, and after that they deflect to the left. This happens due to Coriolis effect caused by Earth's rotation. The Coriolis effect causes the south equatorial current to deflect to the left. Now we will see what happens after deflection. After deflection, the south equatorial current gives birth to another warm current. The name of this current is the Mozambique current. Now, Mozambique current is also marked by red, which means that it is also a warm current, because Mozambique current originates from a warm current which is the south equatorial current, and therefore Mozambique current is also a warm current. Now, Mozambique current flows along the southeast coast of Africa, and we will see what happens next. The Mozambique current flows along the southeast coast of Africa, and then it crosses Madagascar. After crossing Madagascar, it gives birth to another warm current. The name of this current is Agulhas. Now, the Agulhas current is also marked with red, which means that it is also a warm current. And why so? Because Agulhas current originates from a warm current. The name of that current is Mozambique current. So, Mozambique current is a warm current which gives birth to another warm current, which is the Agulhas current. Now, Agulhas current has reached the temperate zone. See, it is below Capricorn. So, Agla's current has reached the temperate zone. Now, we will see what happens when this ocean current has reached the temperate zone. Now, in the temperate zone, a planetary wave named westerlies are very prominent. The westerlies influence the flow of these ocean current, Agla's current, and therefore the Agla's current moves in this direction. Now, we will see what happens next. So, in our previous slide, we saw that Agla's current has drifted this way under the influence of westerlies. Now, Agla's current connects with the west wind drift. Now, let me remind you that west wind drift is a cold current in the southern ocean and it flows in this direction and it does not have much deflection because there is no landmass in the southern ocean to obstruct its flow. So, Agla's current connects with the west wind drift. Now, west wind drift has been marked by blue, which means that it is a cold current. Now, we will see what happens when both these currents combine. So, when the Agla's current, a warm current, connects with the west wind drift, which is a cold current, they give birth to a cold current. The name of this current is the West Australian current. Now, why do we have a cold current? This is because here we have an upwelling of the cold water from deep oceans and also under the influence of west wind drift, which is a cold current whose name is West Australian current originates. And this West Australian current moves along this direction. That is, they travel to the north and here we have a deflection, that is, they deflect northwards because of the Coriolis effect. Due to Coriolis effect, the West Australian current deflects northwards and finally the West Australian current, which is a cold current, connects with the South Equatorial current and completes the gyre. So, this is the complete circulation in the southern part of the Indian Ocean. So, let us recapitulate. In the southern part, the gyre starts with the South Equatorial current, deflects to the left. After deflection, it gives birth to a warm current whose name is Mozambique current. Mozambique current crosses Madagascar. After crossing Madagascar, it gives birth to another warm current. The name of this current is Agla's current. Agla's current combines with the west wind drift and finally, the last current, that is a cold current whose name is the West Australian current, originates. The West Australian current deflects northwards due to Coriolis effect and finally joins the South Equatorial current and the cycle gets completed. So, just see that here the currents move in this manner. That is, here we can find an anti-clockwise movement of ocean currents. So, just like other ocean currents in the southern hemisphere, the currents in other oceans move in anti-clockwise manner in the southern hemisphere. Here also in the southern part of the Indian Oceans, the ocean currents are forming an anti-clockwise pattern. So, we see that in the southern part of the Indian Ocean, the monsoon winds are not prevalent and therefore the usual flow of ocean currents does not get disrupted and so the ocean currents follow the anti-clockwise pattern. So, today we have studied about the complete circulation of ocean currents in the Indian Ocean. Firstly, we have studied about the northern part. We saw that in the northern part, the monsoon winds are very dominant and they influence the movement of ocean currents. In the southern part, the monsoon currents are absent and therefore the ocean currents follow anti-clockwise pattern. And before understanding the circulation of ocean currents in the Indian Ocean, we studied about high pressure and low pressure region over the landmass and the sea in different seasons. And we found that due to difference in temperature and pressure belts, monsoon winds travel from sea to land during summer and from land to sea during winter. And the ocean currents also follow their movement. Don't forget to subscribe to our channel and hit the bell icon. You can also register for free at deltastep.com or download the DeltaStep app to learn one-to-one with our amazing teachers or to get access to our 5,000 amazing videos as per your school syllabus. Master each topic with our adaptive practice technology. Get million-plus questions with step-by-step solutions and unlimited mock tests. Get all your doubt resolved instantly. Learn via games and win amazing prizes like PlayStations and iPads. So at DeltaStep, learning is not just fun and easy, but it's rewarding too. So register for free now.